Hello and welcome, guys. Today's session is going to be on differential calculus. This is AS level. Anybody can join, though. Maths is fun. Right, let's jump straight to it. This is a question taken from a past examination question paper just for practice. Okay, here we go. A piece of wire 30 centimeters long is going to be made into two frames for blowing bubbles. The wire is to be cut into two parts. One part is bent into a circle of radius r centimeters, and the other part is bent into a square of side x centimeters. First part of the question is write down an expression for the perimeter of the circle in terms of r, and hence write down an expression for r in terms of x. Let's tackle that question first. But first, let's do a free body diagram just to understand the question. What have they given us first? What's the data? And what do they want us to find afterwards? Right, let's collect our data. Right, so we are told that we are given a 30 centimeters piece of wire, 30 centimeters piece of wire. From that 30 centimeters, we are to make two shapes, okay? And those shapes are going to be used for blowing bubbles. Right, so the first shape, one of the shapes is a square, and we are told that this square is x centimeters in length. Because it's a square, obviously all the lengths are going to be the same. So that's x, and that is x as well. That side is x. And the second shape we are given is a circle of radius r. Okay, so the radius is r. Right, first part. Write down an expression for the perimeter of the circle in terms of r. Perimeter is the total enclosure. If you start from one point and go all around and come back to the very same point, that's the perimeter. Now, in a circle, that's the circumference of a circle. In mathematics, we call the perimeter of a circle, we know it as the circumference. We know how to calculate the equation for the circumference of the circle. The circumference of the circle is 2 pi r. Now, they said there, write down an expression for the perimeter of the circle in terms of r. There, that's the expression that they wanted. The second part of that very same question reads like, and hence write down an expression for r in terms of x. Write down an expression for r in terms of x. Remember that we started off with 30 centimeters. We cut this into two. One part went into making the square. The other part went into making a circle. But both perimeters, if you add them, they will give you that length, that 30 centimeters. Are you feeling it? Good, let's move on. So now, let's take the square. The perimeter of a square there will just be the total enclosure, or the outside length of the squares added together. So that's going to be 4x. X plus x plus x plus x. So the perimeter of the square, P, is going to be equals to 4x. The perimeter of this circle is 2 pi r. We found it. The total, if we add these two, they must add up to 30 centimeters. So let's add them. If we add those two, 4x plus 2 pi r, that must give us 30 centimeters. Right. Keep your eyes on the ball. They said write r in terms of x. Okay, write r in terms of x. So I'm going to subtract 4x on both sides of the equation. I'm trying to make r to be the subject of the formula. So I'm going to subtract 4x on both sides of the equation. So I end up with 2 pi r is equals to 30 centimeters minus 4x. I'm getting there. Now I've got that 2 pi there multiplied by r. How do I undo a multiplication? Divide on both sides of the equation. So r becomes 30 divided by 2 pi minus 4x divided by 2 pi. So r is equals to 15 divided by pi minus 4 divided by 2x divided by pi. That's just going to be 2x divided by pi. We can rewrite this in a nice simpler version of r as 15 minus 2x divided by a common denominator of pi. That is the first part of the equation answered. Write down r in terms of x. There you go. Second part of the question rather, they said, show that the combined area A of the two shapes can be written as, the area A of the two shapes can be written as A is equals to 4 plus pi x squared minus 60x plus 225. All this divided by how I love pi. Sorry, just couldn't resist. Righty then. Okay, so here we go. Right, so now we are on to area, and they said show that the total area. It's very important to reread, just so you can understand and get a feel of what they're asking. Show that the combined area or the total area, meaning I want to show that the area total, which is area of a circle plus area of a square, will give you that expression. That's what they're asking us to do. Happy with that? Cool. Right, the area of a circle first. So area of a circle is pi r squared. It's pi multiplied by radius squared. If we substitute in, and remember you do have r now, so you are going to do some fancy footwork there. If you substitute in for the r, so you've got area of a circle now being equals to pi multiplied by big bracket, that r there, which you've written, has to be slotted into there. So that's going to be pi multiplied by 15 minus 2x divided by pi. Remember to square it because it's pi r squared. Okay, simplify this a little bit. Area of a circle then will be equals to pi. Now this is to be squared. That square means everything inside the bracket must be multiplied by itself 2 times or FOIL it. Okay, so that becomes 15 minus 2x. Okay, we know how to FOIL first times first, blah 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 blah. I'm just gonna do it quickly. 15 minus 2x all squared becomes 225 minus that's 30. 60 minus 60x plus 4x squared, all of this divided by, don't forget to also square that pi there, divided by that pi. So simplifying this, I can divide that pi into one of those, because remember pi squared is the same as pi times pi, so one of those can divide with that. You're still left with 1 pi at the bottom, or as your denominator in the basement. Okay, right, so a of a circle becomes, remember that and that, they don't cancel, they divide to give you 1. Cancel is not maths. We don't cancel in maths. Okay, it divides to give you a 1. So that's just 1 times. That's why we just don't write it 1 times anything. Is just that thing. So a of a circle is equals to 225 minus 60x plus 4x squared divided by pi. Now, you are saying that this is the area for a circle. Remember, we are looking for the combined area. So we need to add this area of a circle to the area of a square. Area of a square is length times breadth. Area for a square. Area for the square is x times x, or length times breadth. In this case, it's going to be x squared. So take that x squared, add it to this expression to find your combined area, or a subscript t. I'm just going to write it as a subscript t for area total, if you like. Make things simpler for myself and for you as well. So that's going to be area of a square, which we found to be x squared, plus this whole area, which we found to be 225 minus 60x plus 4x squared, and this is divided by pi. Okie dokie. Now remember, folks, this is, we can rewrite that as x squared over 1. We are adding two fractions. We find the lowest common denominator and we divide the denominators from our terms with the lowest common denominator, multiplied by the numerator, all that stuff that you know how to do by now from GCSE. So I'm just going to write it. Area total is equals to, okay, so that's going to be x squared times the pi, and that is going to be plus 225 minus 60x plus 4x squared. All of that will be divided by, because remember we still have a common denominator of pi, all of this will be divided by pi. Okay, apologies, I'm just going to move the board up a little bit. I'm going to move the screen down a little bit just to get the feel of this. Right, so this is what we've got. Now adding like terms. Do we have any like terms? Yes, we do. What are they? They are x squared times pi and 4x squared. Those are our like terms. Add those two. Remember that pi is a number, 4 is a number as well. So if and x squared and x squared, those are our variables, if you like, raised to the power 2. So if we add these like terms, we get area total is equals to, I'm adding these two, so I would have added 4 plus the pi, x, whatever term we're going to get there, or coefficient of x squared we're going to get there, would have been 4 plus pi 22/7, but I'll just leave it as pi, plus 225 minus 60x, all this divided by my pi. Okay, good. So if you look at that expression there, this is what they asked us to prove at the top there. So they asked us to prove that the area total is 4 plus pi x squared minus 60x plus 225. Divide all of that by pi. We've done it. We've proven it, folks. Successfully so. And this is what we ended up with. 4 plus pi x squared plus 225 minus 60x. Those terms are just jumbled up. It's still the same thing. 1 plus 2 and 2 plus 1. You still get the same answer. All of that divided by pi. Thank you, boys and girls. I hope you enjoyed this session on question 7. And I will see you next time. Bye.